Hi guys, welcome to Basic Bit. Today is Saturday and we are on day 5. The problem today is can place flowers. So we have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Given a flower bed containing 0 and 1s, where 0 means empty and 1 means not empty, return if n new flowers can be planted in the flower bed without violating the no adjacent flowers rule. Let's go through the two examples provided by the problem. So in both examples, the original flower beds are the same. There's a flower in the first location and a flower in the last location. In the first problem, it's asking, is there a location in the flower bed to add one new flower? If we added that flower right here, then there wouldn't be any flowers in adjacent locations. So this works. We return true. In the second example, it's asking, can we add 2 new flowers? So the first flower we would add would be right here because we couldn't add it here because it would have an adjacent flower. And then we wouldn't have any remaining locations to add the second flower. If we did add a second flower here, then that would violate the not having any adjacent flowers requirement. So for this example, we would return false. Now let's consider this more general example. So we have a flower bed with 9 locations, and currently there are 2 locations that already have flowers. We want to scan through this flower bed and find locations where we could add flowers in order to find the maximum number of flowers we can add to this flower bed. So we start from 0 and we look at that location. So for this location, we only need to check to make sure that 1 does not contain any flowers. If it's empty, then we can place a flower at 0. So we place a flower here. We cannot place a flower at 1 because it has a left adjacent flower and a right adjacent flower. We can't place the flower at 2 because it already contains a flower. For 3, its left adjacent position has a flower, so we also can't place a flower. For 4, its left adjacent location is empty, its right adjacent location is empty, so we place a flower there. For 5, its left adjacent has a flower, so we keep it empty. For 6, its left adjacent is empty, but its right adjacent has a flower, so it also has to remain empty. 7 already contains a flower, and finally 8 is empty, but its left adjacent location contains a flower. So from this, we can see a couple of things. So first, in determining whether or not we can place a flower at a location, the first thing we need to check is to see if it already contains a flower. The second thing we need to check is its left location and its right location. The requirement is that both left and right of the current location needs to be empty in order for a flower to be added at that location. We're going to want to iterate through every location in the flower bed. So we can do for I flower and enumerate flower bed. And I is going to contain the index of the position, and flower will contain 0 or 1 depending on whether there already is a flower at that index. So if there's not a flower, and if there already is a flower at that location. So if there already is a flower at that location, we're just gonna wanna move ahead to the next iteration of this for loop. One thing we want to be keeping track of this whole time is how many new flowers have been added to the flower bed. So we're gonna call that counter. And we're also gonna wanna keep track of whether or not there is a flower in the position to the left of the current position. So I is going to start out at 0, and it's not going to have any position to its left. So in a way, we can think of the left position starting out as empty. If there is a flower, we can't add a flower, so we're not going to do anything, but we do have to update the value of left to be the current flower in preparation for the next value of I. So if the current position is empty, also, and if there's no flower in the position to its left, then the thing we have to check is whether or not there's a flower in its position to the right. And if there's no flower to the left and no flower to the right, then we can add a flower. So if not flower bed, so to check the value to its right, we have to look at the value at index I plus 1. So if not flower bed index I at 1, flower bed I, we can plant a flower at that location. And we're keeping track of the number of flowers that we plant. And we have to make sure to update the new value of left to be 1. Because if we plant a flower at this location, at the next iteration of the for loop, the left position will have a flower. One thing we have to keep in mind is that when we're checking to see, so if current position is empty and left is empty, and here in this inner if statement, we're checking if right is empty, we have to keep in mind that once we reach the last position in the flower bed, because we're going from left to right, the last position will not have a position to its right. So if we do this I plus 1, we're going to get an index out of bounds error. So we have to handle the last position separately as its own case. So if I equals length of flower bed minus 1, so that's the last position, we are going to plant a flower, because if it reached this point, the last position is empty, its left position is empty, and it doesn't have a right position, so we can just go ahead and plant a flower. And then we can increment the counter plus equals 1. So if we're looking at the last position, we do this. Otherwise, else. Okay, so as we're going through this for loop, flowers are being added to the flower bed. The counter is being incremented. So at each point in the for loop, at the end of the for loop, we do a check to see if the number of flowers we have planted has reached n. And if it has, we can return true. If we go through this entire for loop, check every position, and we're unable to plant n flowers, then we return false. One edge case we have to keep in mind is if n is 0, then it's asking, are we able to add 0 flowers to the flower bed? And so that is always going to return true. So we add an if statement to take care of that edge case. And let's run our code. Okay, this example looks good. We can go ahead and submit. Accepted!